Hello students, welcome back to chemistry class. Today let us continue the lesson, Is matter around us pure? In the previous class we have studied concentration, what is meant by concentration of a solution and what are saturated solution, unsaturated solution and what is solubility. Then we learn how to express the concentration of a solution. We have learned two expressions, mass by mass percentage and mass by volume percentage. Then we learn what is a suspension and we have also learned the examples of suspension and the properties of suspension. Today we are going to learn the topics colloids, then comparison of solution, colloid and suspension. Let us start with the colloid. It is also called as colloidal solution. So you have learnt about solution and suspension, right? So what is solution? Whether we can see the particles in a solution? No, the particles are so small. Whether in suspension we can see the particles? Yes, particles are big. So in colloid, the particle size is in between the solution and suspension. Already we have seen that in solution, the particle size is less than 1 nanometer. But in colloid, the particle size is between 1 to 100 nanometer, between 1 nanometer and 100 nanometer. In suspension, it is more than 100 nanometer. And we have seen already the particle in solution cannot scatter the beam of light because their size is so small. And in suspension, they can scatter the beam of light. In colloid, the particle size is not so small as solution, but not so as big as in suspension. But the particle size is big enough to scatter a beam of light passing through it. So let us see its definition. Colloids are heterogeneous mixtures in which the particle size is too small to be seen with the naked eye, but is big enough to scatter light. That means we cannot see the particle in colloid, but it is big enough to scatter the light. These particles of a colloid appears to be homogeneous, but actually they are heterogeneous mixtures. So just like the solution, colloid also having two components. Are you remembering the components of a solution? Yes, they are solute and solvent. In colloid, the components are called dispersed phase and the dispersion medium. Let us see what are this dispersed phase and dispersion medium. The solute-like component or the dispersed particles in a colloid, that is called the dispersed phase. And the component in which the dispersed phase is suspended is known as the dispersing medium or dispersion medium. So solute-like particles are called the dispersed phase and in which they are distributed or suspended, that is called the dispersing medium or dispersion medium. Now based on the state of this dispersed phase and dispersion medium, there are different types of colloids. That means the dispersed phase can be a solid, dispersing medium can be a liquid. That means solid dispersed in liquid. It can be liquid dispersed in solid or liquid dispersed in liquid. So based on the states of this dispersed phase and dispersion medium, we have different types of colloids. Let us see each one by one. So liquid in gas, that means here the dispersed phase is liquid. That the particles, liquid particles are dispersed in the gaseous medium. Dispersion medium is gas. Such type of colloids are called aerosols. And the example for these aerosols, fog, cloud and mist. Fog and mist are almost same, but fog means we can see within 1000 meter, we can see that. Mist means we can see from far, that means farther than 1000 meter also we can see the mist. Almost both are same. Next type of colloid it is solid dispersed in gas. That means dispersed phase is solid. Solid particles are dispersed in the gaseous medium. Dispersion medium is gas. That is also called aerosol. Example for this, smoke, automobile exhaust. Solid dispersed in gas. Another type of colloid is gas dispersed in liquid. Dispersed phase is gas, dispersion medium is liquid. Gaseous particles are dispersed in the liquid medium. These type of colloids are called foam. Example, shaving cream. Next one, both are in liquid state. Dispersed phase and dispersion medium, both are in the liquid state. Liquid dispersed in liquid. These type of colloids are called emulsions. An example for emulsion, milk, face cream. Next type of colloid, solid in liquid. Solid particles as a dispersed phase, dispersed in the liquid medium. So here the dispersed phase is solid, dispersion medium is in liquid state. They are called sol. Example for solid sols, milk of magnesia. Milk of magnesia means magnesium hydroxide that is dispersed in the water. So magnesium hydroxide is in solid state, water is in the liquid state. Then mud. Next type of colloid it is gas dispersed in solid. Gaseous particles as a dispersed phase. It is dispersed the solid medium. So solid dispersed in medium is in the solid state. They are also called foam. And the example for this, foam rubber, sponge and pumice. Pumice is one type of stone, porous stone. You can see here many pores. Pores means small holes. This is formed during the volcanic eruptions. Next one, liquid in solid. Liquid particles as dispersed phase, dispersed in the medium which is in the solid state. This type of colloids are called gel. Example, jelly, cheese, butter. Next type of colloid it is solid in solid. Both are in solid state. Dispersed phase and dispersion medium both are in solid state. They are called solid sol. Example, colored gemstone, milky glass. So let us summarize what we have studied now. Different types of colloids. So dispersed phase is liquid, dispersing medium is gas. They are called, that type of colloids are called aerosol. Example, fog, cloud, mist. Next one, solid dispersed in gas. That is also called aerosol. Example, smoke, automobile exhaust. Then gas dispersed in liquid. That is called foam. Example, shaving cream. Next, liquid dispersed in liquid. They are called emulsions. Example, milk, face cream. Next, solid dispersed in liquid. That is called sol. Example, milk of magnesia, mud. Then gas dispersed in solid. That is called foam. Example, foam rubber, sponge, pumice. Here there is no comma between foam and rubber. It is one word, foam, rubber. One substance it is. Then liquid dispersed in solid. That is called gel. Example, jelly, cheese, butter. Next, solid dispersed in solid. That is called solid sol. Example, colored gemstone, milky glass. Now let us see the properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. That means we cannot see the particle of the colloid with our naked eye. Colloids are big enough to scatter a beam of light passing through it and make its path visible. Here we can see, we have seen already, milk is an example for colloid. Milk is mixed with water, that is an example. So milk mixed with water, that is an example for colloid. So when a beam of light is passing through the milk colloid, we can see its path. Why? The particle can scatter the beam of light. The particle size is big enough to scatter the beam of light. Next, colloids do not settle down when left undisturbed. That is, a colloid is quite stable. Just like solution also particles cannot settle down. Just like solution, colloidal particles also cannot settle down when it is left undisturbed because they are stable. Next, they cannot be separated from the mixture by the process of filtration. Here we can see a colloid is when we are filtering a colloid through the filter paper, we cannot see the residue, no residue on the filter paper. What's the reason? Colloid particles are very small, they can pass through the pores of the filter paper. So we cannot separate the colloidal particle by filtration. But we can use another technique called centrifugation to separate the particles, colloidal particles. This what is centrifugation? You are going to learn in detail in this lesson later. So let us see once again what are the properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration. But a special technique of separation known as centrifugation can be used to separate the colloidal particles. Next, we have seen now a colloid can scatter a beam of light. This scattering a beam of light by the colloids, that is called Tyndall effect. Tyndall is the scientist's name. So it is after the name of the scientist who discovered this effect. Let us see the examples of Tyndall effect. You are familiar, sometimes we can see a beam of light through a small hole, through our windows because of the dust particle. So Tyndall effect can be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. This you might have observed. Many of you might have observed this Tyndall effect because of the dust particle or smoke that will scatter the beam of light which is passing through a small hole. So we can see the path of the light. Another example, Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. Canopy means upper part of the forest. So here the mist, mist contains water droplets, tiny droplets of water. So these tiny droplets of water that is acting as the particles, colloidal particles, which is dispersed in air. Already you have seen the example, liquid dispersed in gas. One of the example is mist. So in this, these water droplets, liquid medium, liquid particles are dispersed in the air. That means gaseous medium. So these water droplets scatter the beam of light. So we can see the path of the light. These are the two examples for Tyndall effect. Next, let us compare solution, colloid and suspension. Colloids are also called sol. So already we have seen a few points. We can remember now. Solution, the particle cannot be separated by filtration, and the colloid also particles cannot be separated by filtration, but in suspension we can filter and separate the particles. Another one we have seen, solution is homogeneous. Colloid, even though it appears as homogeneous, actually it is heterogeneous, and suspension is heterogeneous. And we have seen if you are keeping the mixture undisturbed, solution, the particles do not settle down. Colloid or sol, the particles do not settle down. But in suspension, the particles settle down. Then what difference we have seen? The size. Size of the particle in the solution is very small. And colloid, it is in between the particle size of the solution and suspension. Suspension, it is big. Then the particle solution is not visible. We cannot see the particles with our naked eye. Colloid also we cannot see with our naked eye. But suspension, the particle, we can see with our naked eye. Let us see the differences. Solution, sol and suspension. Sol means there is a colloid. A solution is a homogeneous mixture. A sol appears to be homogeneous, but actually it is heterogeneous. A suspension is a heterogeneous mixture. Another difference, size of the particles. The size of solute particles in a solution is extremely small. It is less than 1 nanometer in diameter. The size of solute particles in sol is bigger than that of a solution, that of solutions. It is between 1 nanometer and 100 nanometer in diameter. In suspension, let us see, the size of solute particles in a suspension is quite large. It is larger than 100 nanometer in diameter. So here we have seen the size of the solute particles. The solute particles are called the dispersed phase. Another difference, the particles of a solution cannot be seen even with a microscope. In a sol, the particles of most of the sols cannot be seen even with a microscope. The particles of some of the sols can, however, be seen through a high power microscope. What about suspension? The particles of a suspension can be seen easily. Next, let us see the filtration, the separation of the particle by filtration. The particles of a solution pass through a filter paper. So, a solution cannot be separated by filtration. The particles of a sol can pass through the filter paper. So, a sol cannot be separated by filtration. But the particles of a suspension do not pass through the filter paper. So, a suspension can be separated by filtration. Next, let us see the stability. The solutions are very stable. The particles of solute present in a solution do not separate out on keeping. The sols are quite stable. The particles of a sol usually do not separate out on keeping. The suspensions are unstable. The particles of a suspension settle down after some time. Next, let us see the Tyndall effect. That means scattering of light. A true solution does not scatter light because its particles are very, very small. A sol scatters a beam of light passing through it because its particles are fairly large. A suspension scatters a beam of light passing through it because its particles are quite large. So we have seen the differences. We have compared the solution, colloid or sol, and suspension. Its visibility, separation by filtration, its stability, size, and its nature, whether homogeneous or heterogeneous, and Tyndall effect, whether it shows or not. All these we have seen now. So today we have learned the topics. What are colloids? And in colloids, what is meant by dispersed phase and what is a dispersion medium? And we also learned the properties of a colloid. We have learned the examples. Different types of colloids we learned with example based on the state of colloid, the state of dispersed phase and dispersion medium. Then we learn Tyndall effect. Then we learn the comparison of solution, colloid and suspension. Hope you understood today's class, children. Thank you.